Welcome back. In today's video, we'd like to determine the voltage across and the current through each resistor if the input current is 35 amps. Also find the input current if the voltage is 100 volts. So this will be another video under electrical circuit concepts playlist, and you can find that in the top right of the video at this moment. So the first thing, use Ohm's law, we can write the relationship for I, and that is I, the current, is equal to the relationship of V and R, which is V divided over R. So we have the resistance of each resistor. We have the input current, and we do not have the voltage V. So we have the resistors, we have the resistance of each resistor and the input current. Thus, we can find the voltage across and the current through each resistor by using current division, and then using the current through each resistor to find the voltage across each. So let's state a couple more relationships. So the current I through a resistor is equal to the voltage across that resistor divided by the resistance of that resistor. So this could be R1, R2, or R3. We know that V in this case is equal to the input current times the total resistance seen by the voltage source. So we can find the total resistance, which we're going to call R equivalent, and we have three resistors in parallel. Also, we just went over, or in a previous video we went over this same circuit with a little bit of concepts, how to find resistors in parallel. So you can go ahead and watch that, and it'll be linked in the top right of this video, and come back to this one, because we're going to just use the formula for three resistors in parallel instead of deriving it. So the formula is, or equivalent, for three resistors in parallel is the multiplication of all three. So R1 times R2, R3 divided by R2 let's move this down here so we can have some more space. So R equivalent is equal to R1 times R2 times R3, all divided by R1. Well, we omit R1 in the first case, so we're going to omit R1 and write the product of R2 and R3. Then we omit R2, write the product of R1 and R3. We omit R3 and write the product of R1 and R2. So that is the formula for three resistors in parallel. Now that we have the formula, we could go back and take a look and see that the current through a resistor R is equal to the expression for V divided by the resistor R1 or R2 or R3. So let's do that. So the current for I1 is equal to V over R1, which we know the expression for V is the input current times the total resistance seen by the voltage source. So that would be the input current times R equivalent divided by R1. So the input current, we can just use the values, 35 times, and that's divided by R1. R1 is 5 ohms, So then we have 5 times 10 times 20. Then we have 10 times 20 plus 5 times 20 plus 5 times 10. And that will give us a current of 19.9997 amperes. So that's the current through R1. Also, note that the product, the sum, we can sum these in any, we can move this over here and move this over here, still get the same sum when we combine all. But notice that the product of each is what is most important. So the first, you can see that we omit R1 and then we take the product of R2 and R3. For the second, we omit R2, we take the product of R1 and R3. And for the third, we omit the third and take the product of R1 and R2. So then the current through R2 is then equal to, in our case, we could just go ahead and just punch that out, and that is going to equal to approximately 10 amperes. So that's 9.9999 amperes. And the current through R3 is equal to 4.9999 amperes. So we have the input current is equal to 35 amperes, which is equal to 20 plus 10 plus 5. So we see that the current is divided, the input current 35 amperes is divided amongst each resistor. So we're asked to find the voltage. Let's go back. So we're asked to find the input current if the voltage is 100 volts. So normally, because resistors are in parallel, we know that, and we're not doing that portion of the problem. So we're not doing this portion of the problem. Normally when I do a problem like this, I want to find out what the voltage source is, because if you remember, we did not get the value of the voltage source. So because resistors in parallel have the same voltage, we know that the voltage, oh by the way, the voltage across. So we find the current through each resistor, so now we need to find the voltage across each. So we know that the voltage across resistors in parallel are equal to the same. So we know that the R1, R2, and R3, so the voltage across R1, R2, and R3 is equal to the same. So we can use the current through R3 times the value of R3, so the resistance of R3, and that'll give us 99.9985 volts. So the voltage, actually the voltage across each of the resistors is equal to 100 volts. So it's a source voltage. So as you can see, the second part of the problem asks us to find the input current if the voltage is 100 volts. And because we found the voltage across each resistor to be 100 volts, and we know that each resistor in parallel connected across a voltage source V sees the same voltage that is equal to the value of that voltage source. So each resistor connected in parallel across a voltage source V sees the same voltage as the voltage source V. So we can deduce that the input current, so the input current is equal to 35 amperes when the source voltage is equal to 100 volts. So before we end this video, we can take a look in LT Spice. So I can go ahead and enable these. So you can see we have the same circuit, same resistor values. And now we have a voltage source with a voltage of 100 volts. So we can see that the current through R1 is 20 amperes. The current through R2 is equal to 10 amperes. And the current through R3 is equal to 5 amperes. So notice that the voltage across R1 is equal to 100 volts. The voltage across R2 is equal to 100 volts. And the voltage across R3 is equal to 100 volts. So each of the resistors connected in the parallel network, connected across a voltage source V, sees the same voltage from the source. So each of these resistors see the same voltage, so 100 volts, 100 volts, and 100 volts. The only thing is that the current is divided up. So the input current entering the node is 35 amperes. So as you can see, negative 35, because in this case, you see where the current arrow is heading, so it's flowing in a negative direction, so that's 35 amperes. So that's it for today's video. So I'll see you in the next one. Bye.